scientists! In our last lesson, we reviewed the 3 states of matter. Today, we'll look at water molecules and how they change when the temperature changes.
Now, let's get down to the tiniest little part of water that you can get. We're going to talk about water molecules. A water molecule is the smallest piece of water that you can possibly get. If you could look through a scientist's microscope, you might be able to see one. They're very tiny. So when I show you this picture, you know that they don't really look exactly like this, do they? Because first of all, would a water molecule be this big if it's the tiniest possible piece of water you can get? Of course not. And would a water molecule be red and white? Of course not. This is just an artist's drawing to help you see the separate parts. And the drawing is to show you that 1 part is oxygen and 2 parts are hydrogen, and they're all just stuck together, and that's what makes water. By the way, if you turn it this way, it looks like a certain famous mouse. Help you remember what it looks like. So, a water molecule looks like this. And if you could have microscopic vision, you could see every tiny little thing, you would see that when my liquid water went splat on my table, the reason it didn't stay in a nice, neat little shape is because that water was kind of moving around. When water is liquid, those molecules are just moving around, kind of slowly usually. And then, as those molecules get warmer and warmer and warmer, picture like if I had my drops of water here and it got really hot in here, they wouldn't stay there forever, would they? They would dry up or evaporate. That's because those molecules start moving faster and faster and faster and faster, 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 until they quickly move up into the air and they dry up and they evaporate and they change to water vapor. When water molecules get really warm, they change from a liquid to a gas. Now, likewise, when they're gas, if it starts cooling down, then they're going to start changing again. Remember when I blew a hot breath on my cool cup? This cool cup cooled down that water vapor enough to make it liquid for just a moment. So water vapor, those water molecules, this water vapor can cool down enough to slow them down and turn them back into liquid. Now finally, if you get water cold enough, remember below 32 degrees Fahrenheit, that water can change from a liquid to a solid. That's right, frozen, ice, stuck. But here's a really fascinating thing. Remember those little molecules I mentioned that are either moving fast or slow or not at all? Well, when they're not moving at all and they're frozen as ice, they link up in this really neat, specific way. And this is very special for water. Not everything does this. But when water freezes, it links up so that those hydrogen parts touch the oxygen parts of the other water molecules. That's the only way they can link up. And when they do that, because of their shape and because of the way that they have to touch each other, they leave all of this open space in between. Look, it's beautiful. It's almost like a snowflake or like an ice crystal with all those beautiful spaces in between. So it looks like it takes up more space. When water's liquid, even though those little molecules are moving around, they can be nice and tight in a jumble, like this picture shows. So water does really, really interesting things when it freezes. And it's different when it changes to a solid than other substances are when they change to a solid.
See you next time when we will explore more Water Matters.